Hello and welcome to the Argyle Cybersecurity Solutions CISO Summit. My name is Vicki Lynn Brunskill with Argyle. It's great to have everyone joining us today. Just a couple of notes before I turn things over to our esteemed speaker for the session. First, a quick reminder to stop by our sponsor's virtual booth at any time during today's event and for the following week. Our partner is committed to providing you with valuable content and a great overall experience today. And at any time during the event, you can visit their virtual booth from the main agenda page, which includes complimentary materials, information, and meet and greet opportunities. To ask questions throughout this session, simply type into the Q&A chat. We'll address your questions at the end of the session. And now, without further delay, I'd like to introduce our speaker, Greg Sloan, Cloud Security Specialist at Lacework. We are so excited to have Gregory with us for a thought leadership and demo presentation titled Cloud Security, Making Everything You Build Cloud Secure. Welcome, Greg, and over to you.
Hello, thank you, Vicki Lynn. Welcome to our presentation. Over the next 40 minutes or so, I'm going to be going through an overview of Lacework's view of the challenges in cloud security and how Lacework addresses them. I'll be going through a demo of the Lacework Polygraph data platform, and then hopefully at the end, if I'm paying attention to time, there'll be a few minutes for some Q&A. So let's get started. My name is Greg Sloan. I have been at Lacework for a little over 2 years now, and seen us grow from a couple of hundred dedicated people to over 1,000. And I came to Lacework because in the time I spent previous to that in the world of DevOps, particularly around automating compliance, it really taught me that the state of cloud security is a big stumbling block to the efficacy and velocity of development and innovation in the cloud. And I saw that Lacework offers a really unique perspective on solving that. That got me really excited to come here. To understand what Lacework does differently that excited me, let's take a look at the landscape that Lacework was built to help with. Companies have embraced the cloud as the platform for innovation and growth. Then they've restructured business and technical practices to take advantage of the near limitless scale that cloud offers them. From agile development, allowing developers to fully own the code that they're working on, to building teams that encompass a deep technical understanding to harness multiple clouds, as well as taking advantage of the underlying technologies that supports those business roles, shifting more into developer hands with automated pipelines and containers, while managing the technical side at scale with orchestration and defining everything as code. However, this acceleration of growth, new technologies and new business practices has left a big gap, right? You as CISOs are likely trying to manage this new scale of business faster than you're able to find qualified security professionals to keep up with that and manage your secure state. This gap is introducing risk, and we can't close it through humans alone. It is accelerating too quickly for us to scale our human capital to keep up with it. And so security automation is necessary to support this growth in business that we're seeing due to the cloud. Attempts at closing this gap with traditional security tooling and approaches have largely failed. Many companies are using a catalog of tools to cover different areas of visibility or different environments, multi-cloud architecture. A Gartner 2020 survey shows that 78% of CISOs have over 16 security tools in their organization, and 12% have as many as 45 or more security tools. This makes it very difficult to maintain a coherent view of security across environments and teams, and add significant overhead to manage and maintain all these tools. We already don't have enough engineers to do the work we need them to do, let alone now becoming managers of a whole software fleet of tools. On top of that, the tools that are there are largely using legacy rules-based methods to define security. These rules operate on a couple of assumptions that fail to hold in the cloud environment. One of those assumptions is that there is a finite definition of the secure state in the cloud. But we all know the fact is cloud changes frequently, right? Environment to environment, application to application, day to day, hour to hour, there's new services that are brought online. Keeping up with that rate of change in our rule definitions is an impossible task. But more importantly, the attackers are just as aware of how those rules work and are constantly changing their tactics to evade them. A rule-based approach will never detect the new, novel, unknown threats that we don't have a rule for yet. That's why we continue to hear about successful zero-day attacks. Traditional approaches also leave compliance as an afterthought. It's a costly and time-consuming process that's relegated to once or twice per year. And so not only are our security teams occupied with this time-consuming and error-prone manual evidence collection to satisfy auditors, but they are left in the time between those audits without insight into the state of their cloud security in their environment, right? And the cloud is in flux between those audit points. So we're blind to what we may be at risk to. You put all of this together, and it represents a significant cost and a complexity penalty in our environment, whether it's the cost of maintaining those 16, 20, 40 more tools, the cost of writing and rewriting rules to keep up, or the ultimate cost of finding yourself vulnerable to a security breach because you weren't able to make sense of the vast data that's coming in from all these disparate tools. Our businesses are spending a huge amount of money and effort on not finding themselves much more secure in the cloud. If we can't automate the analysis and correlation of data that's coming in, all the tools in the world will not close that gap for us. Lacework's solution has been to create a unified platform and model that starts with bringing all the security data we care about across the software development lifecycle into one place. This will not only deliver better secure outcomes, but enable better collaboration across the various functions of our business. With everything in one platform, we can understand the complex relationships between entities, processes, connections, to understand what is actually happening in your cloud specific to your business and environment. With this data, Lacework can apply both policy-based and, critically, behavioral-based modeling to detect potential and active threats. While it continues to be critical to minimize risk by finding the known vulnerabilities and misconfigurations, it's vital to recognize that risk can never be reduced to zero, particularly in the cloud. So for those unknown, novel threats that we can't write policies to prevent, Lacework employs behavior-based detection to identify unusual and anomalous activity that can indicate an active threat in your environment. And it accomplishes this fully automatically without the need to write, rewrite, and maintain rules. With native integration across cloud and workload architecture, Lacework can automatically scale with the environment, providing continuous protection, allowing the business to scale without needing to scale the human workforce to maintain visibility. From code to running in production, Lacework both ensures that risk is minimized by eliminating known weaknesses that could be exploited early and continuously monitoring what's happening on your workloads and in your cloud control planes to quickly and effectively alert you to active threats. And when those threats come in, when those alerts come in, Lacework provides we're able to provide invaluable context with those alerts. With the Lacework Polygraph Data Platform, you know where in your environment an alert happened, what other resources are involved, what users and credentials are used, what potential paths attackers have into your cloud, what resources are at risk should those attack paths be exploited, which potential risks are running in your critical exposed resources versus just installed, not active, running on low value internal only resources. All of this happens automatically within a single tool, and this helps teams prioritize that risk and significantly speeds up incident detection and investigation times. Before I jump into the platform to actually show you what all this looks like, I want to give you a preview of the areas that Lacework covers. To put it in industry terms, Lacework operates across these CNAPP functions with broad goals of prioritizing your security risk in the cloud, finding known and unknown threats faster, increasing the operational efficiency of your security practice, and achieving that continuous cloud compliance across your environment, again, from code to production. As a result of this, our customers realize massive reductions in the number of alerts they have to deal with, use the context of those alerts to accelerate investigation, and greatly reduce the amount of manual effort spent on security operations, right? So Lacework is really helping security practices reduce their spend, effort, and risk, both upfront before security events happen, by securing everything, making it easier to find things in a shift-left environment early in that development lifecycle, and saving that time and effort in the event of an active incident by giving you the context in one place and one tool that you can investigate effectively and efficiently with fewer resources. All right. And with that, I will let you see the actual product so you can see what I'm talking about. Okay. All right, cool. Thank you. I got confirmation that my screen is being shared. So this is a summary of what we're doing with that data coming in, right? Lacework, like I said, we start with the data rather than assuming we know what secure looks like and trying to apply, we're looking for this is secure in your environment, which leads to noise, that time and effort managing, maintaining, and tuning what that definition of security is. Lacework instead pulls data in from your cloud audit logs, network connections, process information, files, cloud resources. We bring all of that in. And from that huge amount of data, this is just our little demo environment, 5 million pieces of data over the last few days. We see customers typically in the billions of individual pieces of data that Lacework is processing. We analyze that hour by hour, and we define behaviors that data represents. These are full end-to-end interactions that users and processes make, whether it's API calls, traversals across the network, applications running and making connections in and out of the environment. And you can use this as kind of a, we like to think of it as an analog for the rules that you would have to write to accurately define what is secure in your environment, right? This is what your environment is doing on an hour-by-hour basis. And if things don't match that, we want to know. To get that from a rules-based platform, you would have to define this behavior in a rules language continuously as your environment grows and evolves. Lacework does that entirely automatically. And from that, we can alert on just those behaviors that do not match what we have learned is normal in your environment. The normal processes and connections and API calls and user interactions that are being made for your day-to-day business. Lacework automatically finds those, and from the context that we have, we can understand, is it anomalous enough and is it touching critical enough pieces to raise it to that high and critical level? So from 5 million pieces of data, we're down to just a handful of alerts that we have to spend time investigating, okay? So what does that look like? The result of that is our polygraph. Polygraph is a visual representation of those behaviors that I've just described. And it's going to tell you what happens. In this case, this is our CloudTrail polygraph. This is analyzed from CloudTrail events that we're reading directly from our our AWS account. And we are building either in a small environment or broadly across all of our all of our accounts. We're building a map of what accounts are being connected to, from where, using what credentials, and what API calls are being made against what regions, the API service, specific API call, and the end result of those calls. Right? We are building this out hour by hour and what's happening. And so now we have an understanding of what is normal, right? Where are these credentials used from? What API calls do they make? What accounts are they used against? So then when we see a login from a location that we haven't seen that credential in before, as highlighted here in red, and then a new credential being used to make calls that we have not seen before, that's going to stand out We don't have to write any queries. We don't have to guess what this might be. This may be a new way that our system has been compromised that we didn't know was even possible before. Lacework is going to recognize that this is a new pattern of behavior and generate an alert. That alert is going to give the detail that is necessary to investigate this and understand everything we need to know to either shut this down. Maybe it is something that's just a new behavior, something new has spun up, but it's interesting to know and good to know from a security standpoint what's happening in our environment. But we're going to learn from the event what account was involved, the user, where that came from, the time frame, what else that user was doing, so we can see the API calls that were being made. In this case, they created a new user, deleted access keys, deleted users. These are all put together, form a picture of what happened here. This looks like someone has gotten into our environment, potentially created a user with access keys to our environment, and potentially breached our systems. As we dig further in, we see related alerts that are also involved. So we could see that full path of attack from entry to execution of the attack to the S3 bucket being deleted, S3 being accessed. So it looks like we have both a potential credentials compromise and potential data breach risk here, right? All within one platform without having to go to other tools to collect this various logs, without having to query this data ourselves. Lacework has automatically teased out and provided that context for us. So cloud API, cloud control plane security is one domain that we do that in. We are also doing that against your running workloads, applications that are running on your environment within the cloud. Right? Those workloads can be containerized or not. At some level, Lacework doesn't care. At some level, all activity is processes running on hosts and making network connections, right? That defines our behavior of our applications and the users that are interacting with those applications. We recognize when they are containerized and provide that context so that when an incident does happen, you can investigate that, understand where that application lives, what node it's running on if it's in a Kubernetes environment, namespace, and all the details you need to identify the specifics of that container and application. We are building out, again, this polygraph of what is happening, right? As users connect in from external sources, the application handles that incoming connection, then that application generates other activity. It may connect to other backend services internal to the environment, which then potentially reach out to other services internally, or maybe are making external connections out to APIs or other external accounts. Again, building that hour by hour understanding of what behavior is happening in our environment so that we can identify new potentially threatening activity in the environment automatically and quickly. Okay. So, for example, back up here, we have our application. Now, I'm being informed here on the polygraph that with this icon here, that there is a potential vulnerability in this application, right? I've talked a lot about the behavioral and the unknown ability to detect unknown threats. That doesn't mean we are ignoring the known, right? We are going to look at vulnerabilities in your environment. We're going to find those published CVEs and let you know where those vulnerable applications and processes live in your environment. We're going to look for known configuration issues and let you know about those so you can minimize the risk as much as possible. This is making sure that your doors and windows are locked and your security system is turned on. These are important things to do, and Lacework is going to help you too. However, we have to assume that even if we do all of that, I don't know about the tunnel underneath the floor of my building that the attackers are digging right now. I don't have a way to look for that and write a rule. There's no CVE published to alert me to it. So while we will let you know that something is vulnerable, we do not 100% rely on that and assume that getting rid of those vulnerabilities makes us safe. So if we flash back to a year and a half ago, when there was no way I could give you this alert that there's a log4j vulnerable Java library running in their environment, because the only people who knew about that were the people who were looking to exploit it. And my application, my e-commerce application is running. It's accepting internal connections. It's talking to its backend services, login service, a order service, which in turn talks to a data inventory database, as well as a SQL Server to store those orders. That's what it does all day. Lacework has watched this activity. It knows what these containers are. It knows what those containers talk to. So that the next hour, all of a sudden, that Java application reaches out to an unknown LDAP network it's never done before and starts pulling code from PyPy and other external sources and reaching out to endpoints we haven't seen before and reaching out to S3 buckets. This is going to be alerted on by Lacework. Now, again, today, most of us may be able to recognize this by sight, that this is a Log4j exploit. We know what that is now. I can today write the rules to look for that. I can write the rules to block LDAP access from Java applications. I could not do that a year and a half ago. And I can't do that for the next 0 day that we don't have a name for yet, that we do not have a CVE for yet, that we don't know what that behavior is. There is no rule that is going to protect me from that. However, Lacework will immediately, if that exploit is used, alert and say, there is something anomalous happening here. This application, this process, this host doesn't act like this in your environment, right? And that is very specific to your environment. It make assumptions based on the industry and what other users and other companies do and other organizations. It is your specific environment, your application's behavior. This is what we based our detections on. Similar to that CloudTrail alert, we're going to offer alerting for this application domain. That's going to give you the details that you need. It's going to tell you where this is happening, what host it's on, the application involved, the host it's running on. We can identify whether these applications that are involved are exposed to the internet. So is there a real path in here that someone could and has exploited? And if so, what do I need to do to remediate that and block that access? As well as I can start to understand what the blast radius is, right? I have an EC2 instance here. EC2 instances come attached to often privileged IAM roles. And if anyone were to be able to exploit and get onto this EC2 box, they would have implicit access to those IAM roles so they can do more damage in your environment. So here I am highlighting what this resource is, how someone may be able to get in, and what they can do with that. So again, being able to prioritize that risk and understand, is this something that I should take care of today because it's wide open to the world and has an active vulnerability, right? We're calling out the vulnerability information we have on the system directly in here, so I can start to understand that and scope out what it'll take to patch this to be secure. If there were secrets hosted on this system, so SSH keys, AWS keys, those kinds of things, these are, again, raise the potential risk that a breach of this system represents. So allows me to, again, prioritize where to spend my time. We're going to give you the details of the machine, where this lives, all the tagging information. So as someone responsible for this, I can identify it. This information can be used to route these alerts off of the Lacework platform to wherever is most helpful for your organization, whether that's a ticketing system, an internal communication system like Slack or email, a SIM to add further details and context that Lacework doesn't provide around application performance monitoring or anything else you're tracking in your SIM to start correlating that together. We're going to provide the details of that security group so we can understand, is this open to the world? Should it be? What needs to change to be able to lock that down if I want to? All of that here within this tool, everything I've gone through. Oh, and actually, for the actual incident itself, we call out, again, what's happening, the actual application involved, all the way down to the process details and the command line that was used to execute it, okay? So if you take a step back and look at this one alert and think about all of the data I just presented, inventory data on the cloud, application data running on the host, container information about how that application is running in my environment. Configuration information of the cloud itself. Think about the number of tools that represents that in a traditional world, an engineer, someone responding to this incident, would have to log into, check, correlate between, find all this information. All of it is presented right here in one place for you to manage. Right? And this is how we achieve that significant 80% reduction in the time to investigate and remediate incidents in the wild by correlating and giving context to these alerts, while also reducing the number of alerts and reducing the effort needed to make sense of the data coming in. Right? So I spent a lot of breath on the behavioral view. It is our biggest differentiator, is what we do differently and we consider most critical in the industry. However, as I also said, we do cover the basics of making sure that your vulnerabilities are identified. We're going to scan hosts and container images as early as developer laptop, into the pipeline, into the repository, and into the running containers in your environment. So we get that full end-to-end continuous view of what vulnerabilities exist, get them out early in the pipeline, and also make sure that nothing is introduced in the running environment, as well as identifying not just which vulnerabilities you have and giving you a big unsortable list of what is out there, right? We've all had to deal with the reports of all the thousands of vulnerabilities that exist in my environment and not knowing where to start. But we can also identify where these resources are running in my environment. Which ones, for example, are running on hosts that have that internet exposure, that exposure graph I showed. We are able to sort these vulnerabilities and prioritize it based on ones that are exploitable from external sources on the internet. Okay. We will also check the compliance state of your environment. Our base, we run CIS as our benchmark. We also have our own security team that comes up with controls beyond what CIS covers. And we will produce reports that tell you what resources are in and out of compliance, give you tracking information so you can track your progress towards compliance. Identify if we do see something that's out of compliance, we'll identify what that resource is, where that lives, the account. We give you links to that. We actually track the configuration, so you have access to that. And we provide definitions of these compliance rules. So again, context is our favorite word. We're going to identify what the rule is, why it exists, how we're checking it, and how to remediate it, so that when you get this information, again, in your ticketing system, within the Lacework platform, as a report that's easily consumable, however you get that, you have the details you need to understand it and remediate it. We will also take these compliance controls and correlate them into reports for specific audits. So if you're trying to prove audit for SOC 2, NIST, HIPAA, ISO, PCI, these reports will identify, here is a control for SOC 2 that we have a requirement that we have to meet. These are the technical controls that I've implemented and validated and their state. And that will tell me how close I am to being SOC 2 compliant. And when it is time for audit, I can quickly and easily export this audit or this and hand it to the auditor as evidence of my compliance state. Right. So coming up on time, I think that's everything I wanted to show on the demo. I think there might be some Q&A questions, so I'll pause there and hand it back to Vicki Lynn.
Thank you so much, Greg. Wow, that's so much good information in that presentation. Thank you for that.
Hey.
We do have a few questions that came in from the audience. Our first question is, what do you think, this is a big question, what do you think is the biggest challenge in cloud security today?
That's a great question. You know, I think I covered some of that in the presentation, but it's really good to go back to it. I think the biggest challenge is scale. Right. I think the scale and breadth of the cloud has outpaced our ability to keep up with security at a human scale. Right. We can't expect to know what secure looks like. We can't expect a team to be able to continually keep up with what rules would need to be written and maintained and rewritten and remaintained for every new environment, every new application. It changes too much, right? So I think the biggest is just the amount of data that represents our secure state and our inability to consume that without automation.
Thank you so much. The next question that we got from the audience is, which aspects of cloud security are best suited for automation and why?
I think the low-hanging fruit, the easiest thing is around the kind of that last piece I went through, cloud compliance. That is the locking your doors and windows and making making sure your security system is turned on analogy I gave, right? That is represented by a pretty static understanding of data. We can pretty straightforwardly analyze that, give binary yes, no, doesn't match the standard that I set out results, and act upon those, right? We can take the results, yes or no, is this in compliance or not? If not, I can then pass it on to automation to then remediate, right? I didn't mention it in the demo, but we can do these checks either against running systems, running cloud environments, or we can do it against infrastructure as code. If you're defining that before you deploy it, we can run those same checks. So as early on as possible, we can automatically remove those misconfigurations and obvious compliance issues very early on. Now, Lacework is obviously trying to expand what's easily automatable, but the behavioral piece is less easy. That's why we have patented methods of doing it, and it's not being done by everybody, so it's less easy, but it's equally important, and Lacework's trying to tackle it. But if you want, hey, something I can automate today, absolutely compliance is the way to go.
Perfect. Thank you. The last question I see here is, what is the general time frame to implement the Lacework solution you demonstrated today?
It's a really good question, right? I didn't really get into it, but one of the big challenges that people see with a lot of security software is implementation and efficacy, right? Spending the time to tune those rules, to tune out the noise. And it takes time to deploy them. They're heavy. They have agents that have been, I don't think I'm stepping out of line here. Agents have been known to impact running workloads. We're really sensitive to that. So Lacework is deployed kind of two main ways or components to our deployment. There's what we call our agentless deployments, which involve just deploying some roles in your cloud environment with read-only permissions for us to access logs and configuration data. And then we do have a data collector that runs as an agent on your workloads. It's very lightweight. It runs with no kernel modules, user space only, so it's completely low to no impact. We typically run about 1% of CPU and memory across environment, and all of that typically takes about 1 to 2 hours for our customers to deploy. We will deploy it in a POC. Everything I've said here, I don't expect you to take my word for it. We're happy to go and do a POC in your actual environment. If you'll let us get to production in the POC, we will happily deploy across your production environment. And again, that typically takes 1 to 2 hours to do deployment. And at that point, everything else happens automatically. All the tuning, the learning, all of that happens completely automatically. So we start to see value within about 3 to 4 days.
That is not the answer I thought. That's pretty fast. Thank you so much, Greg. Thank you for the wonderful presentation, the wonderful demo today. We really do appreciate you being with us. I want to thank everyone for joining us today as well. Greg's LinkedIn information is included on our site, and so that you can click right through, and I know that he'd love to hear from you. This session, along with all of today's content, is also available on demand following the event. Thank you again, Greg.
Thank you.